Good evening. Today's quote is by Napoleon Hill. A goal is a dream with a deadline. A goal is a dream with a deadline. Today's word is cacophony, a mixture of loud, unpleasant sounds, noise, cacophony of a large city. In last lecture, we discussed De Moivre's theorem. Today, we are going to discuss an interesting subtopic of this, that is cube roots of unity. What do you mean by unity? Unity means one. So cube roots of unity means roots of the equation x cube equal to 1. Now x cube equal to 1 can be written as what? X cube minus 1 equal to 0. What are the factors? X minus 1, x square plus x plus 1 equal to 0. So either x minus 1 is 0 or x square plus x plus 1 equal to 0. Clearly x equal to 1. Now we cannot find the factors of x square plus x plus 1 equal to 0 by factorization method. So we use the formula. I hope you know the formula for finding roots of a quadratic equation. I will not mention that formula. I will directly write the roots. Minus b, so minus 1 plus minus root of b square, that is 1 square minus 1. 1 square is 1 minus 4ac. Now a is 1, c is also 1 upon 2 times 1. Now I simplify this further. Minus 1 plus minus. Now it is root of minus 3. What is root of minus 3? It is root 3 into root minus 1. But root minus 1 is I. That is imaginary unit. Okay. So these are the two roots of which equation? X square plus x plus 1 equal to 0. So can I say that cube roots of unity are 1, minus 1 plus root 3i upon 2. This is very interesting. And then minus 1 minus root 3i upon 2. So these are the three cube roots of unity. Clearly, one root is real and remaining two are complex conjugates of each other. See whether you remember this or not. We have done this. If this is alpha and this is beta, we have already proved that alpha square equal to beta and beta square equal to alpha. You can verify. If you square, see the cursor, if you square this complex root, you get this one. And if you square this, you get this one. And therefore, next part is important. Therefore, we denote one of the two complex roots by omega. We have discussed Greek alphabets. This is small omega. You have already used capital omega. Ohm, unit of resistance. This is small omega. So small omega is used to denote one of the cube roots of unity. So you may say it is minus 1 plus root 3i upon 2. Or you may take it as minus 1 minus root 3i upon 2. Is that clear? And therefore, I will say that cube roots of unity are 1 omega omega square. Note that omega is basically root of which equation? X square plus x plus 1 equal to 0. As it is root, I will say equation is satisfied by omega. Therefore, omega square plus omega plus 1 equal to 0. You can use this as standard result. Rearrange the terms. If you rearrange the terms, then 1 plus omega is minus omega square. What will be 1 plus omega square? 1 plus omega square will be minus omega, and 1 rather omega plus omega square is nothing but minus 1. Now we say that omega is cube root of unity, means it is root of which equation? x cube equal to 1. As it is root of the equation, it will satisfy the equation. So omega cube is nothing but 1. You can verify this. What is omega? Omega is either this or -1 minus root 3 by 2. If you cube this, you will notice that you get 1. So omega cube is nothing but 1. Is that clear? See, I'm going to explain this part once again. Don't worry. Please do not type in chat box before I finish the explanation part. Please explain again. Please explain again. I am going to explain. See, I will explain till each and every student understand the concept. So don't worry about that. Okay. Now, what are the integral powers of omega? You have to use common sense. See, omega cube is 1. So if I ask you to find what is omega raised to 4, it is what? It is omega cube into omega. But omega cube is 1. 1 into omega is omega. What will be omega raised to 5? Omega raised to 5 is omega cube into omega square. But omega cube is 1. 1 into omega square. Okay. In general, if n is a natural number, what is omega raised to 3n? I can write this as omega cube raised to n. But note that omega cube is 1. 1 raised to n is nothing but 1. Okay. So this is nothing but, rather this is information or results which we can obtain from cube roots of unity. Write down, give the title cube roots of unity. In that, write down cube roots of unity, that is roots of the equation, x cube equal to 1, that is roots of the equation x cube equal to 1 are are 1 omega square, where omega equal to -1 plus I root 3 upon 2 or -1 minus I root 3 upon 2. Right now. Then write down omega cube is 1. One plus omega square equal to 0. So 1 plus omega minus omega square. 1 plus omega square minus omega. And omega plus omega square equal to -1. Remember, these two are standard results. Which two? Omega cube is 1 and 1 plus omega square equal to 0. These are a derived result. So you should not write 1 plus omega is equal to minus omega square directly. First, you should say 1 plus omega square is 0. So 1 plus omega is minus omega square. Okay. Yes. That's it. One student is asking, but how do we get x cube equal to 1? Okay, I'll explain that also. See, what is our aim? To find cube root of unity. So I will say, let x be cube root of unity. Unity means 1. Cube root means raised to 1 upon 3. Let x be that cube root of unity. On cubing both sides, you get x cube equal to 1. This is how we get equation x cube equal to 1. Is that clear? Exercise 1.4, first sum, find the values of number 1, omega raised to 18. Now positive integral powers are defined, so omega cube raised to 6. Omega cube is 1, 1 raised to 6, 1. Omega raised to 21 is omega cube raised to 7. Omega cube is 1, 1 raised to 7 is 1. Omega raised to minus 30, strictly you have to write this as 1 upon omega raised to 30, that is 1 upon omega cube raised to 10. Every time you have to say omega cube is 1, omega cube is 1, 1 raised to 10 is 1, so answer is 1. What is omega raised to minus 105? It is 1 upon omega raised to 105. Now 105 is multiple of 3. Omega cube is 1, 1 raised to 35 is 1. So what is the final answer? It is 1 only. Now, second question. If omega is a complex cube root of unity, then show that. First part, begin with LHS. If you ask the reason for this, I'll say common sense. How can you start with 7 and obtain LHS? One can just begin with LHS, obtain RHS, and consider steps, last step first in the reverse order. Now, LHS is 2 minus omega, 2 minus omega square. Open all the brackets. Omega cube is 1. Now I will say as 1 plus omega square equal to 0. You can treat this as standard result. Omega square plus omega is minus 1. Substitute. So LHS 4 minus 2 minus 1 plus 1. This is nothing but 7, which is right hand side. After that, you have to say that is 2 minus omega. This is important. See, for presentation, marks are there. Okay, that's it. Actually, after sufficient practice, let me explain. You may say, can we write this as, see these two terms, can we write here only 1 plus omega square minus 1. Why? Because it is just omega square plus omega. But we will add 1 so that this becomes 0. We cannot just add 1, we have to subtract 1. Yes, that is why this is minus 1. But some students, they do not understand this. That is why I have written this separately. Second, LHS 1 plus omega minus omega square raised to 6. Now 1 plus omega square equal to 0. So 1 plus omega is minus omega square. So this becomes minus 2 omega square raised to 6 minus 2 raised to 6. If index is even, answer is positive. So 64. What is omega square raised to 6? Omega raised to 12. So omega raised to 12 is omega cube raised to 4. Omega cube is 1. 1 raised to 4 is 1. So 64. Third one, 1 plus omega cube minus 1 plus omega square cube equal to 0. We have to prove this. You may say, can we use a plus b bracket cube formula? Yes, you can. But why to use that? See, we know 1 plus omega square is 0. So I write that. But is it 1 plus omega square? No, it is just 1 plus omega. So subtract omega square. We have written the same in different form, so that I can replace this by 0. Okay, what about 1 plus omega square? It is 1 plus omega square minus omega. So this is 0 minus omega square cube minus, not plus, here negative sign is there between two, minus in bracket 0 minus omega cube. Now what is cube of minus omega square? It is minus omega raised to 6 minus, what is cube of minus omega? Minus omega cube. Omega cube is 1. I'll explain this part first. So minus 1, minus minus plus 1. What about this? Minus as it is. Now omega raised to 6 is omega cube square. Omega cube is 1 square. Now you may ask me, but sir, minus 1 square is plus 1. I also know that. But it is minus into 1 square. 1 square is 1. That is why minus 1. So minus 1 plus 1, 0, which is nothing but right hand side. You are not supposed to write this directly. You are supposed to mention this. This step is required. Actually, one student is saying, I use different method. Is it okay? Actually, any correct method will be given or should be given full credit. As we are not in classroom, I cannot verify whether the method used is correct or not. But if the method is correct, fine. And I don't think there is much scope in this case to use altogether different method, but still it is allowed. Okay, now the next one. I will underline this and here I'll consider this as, write down 1 plus omega square equal to 0. What is omega plus omega square? It is minus 1. And what is 1 plus omega square? It is nothing but minus omega. See, all these are playgroup sums. So this is 2, omega plus omega square is minus 1. So 2 minus 1 cube minus, now 1 plus omega square is minus omega. Minus omega, already minus 3 omegas are there. You have to consider that also. Now what is 1 cube? 1 cube is 1 minus. Now minus omega minus 3 omega. So I will write minus 4 omega cube. You have to be very careful about the signs. What is cube of minus 4 omega? It is minus 64 omega cube. Open the bracket. So 1 minus minus plus 64. And what is omega cube? Omega cube is 1. So this is 65. Yes, same as right hand side. But after this, you have to again write, that is, what does this stand for? This stands for 2 plus omega square cube minus 1 minus 3 omega plus omega square cube equal to 65. Write down. Sum number 5, we begin with LHS. Now take 3 common from first two terms and then replace 1 plus omega by what? Minus omega square. In second bracket, take 2 common from first and third. And in that, 1 plus omega square is to be replaced by what? Minus omega. Simple. Now this is 2 omega square raised to 6 and this is 4 omega cube. So 64 2 raised to 6 is 64. Omega raised to 12 minus 64 omega cube. Omega raised to 12 is fourth power of omega cube, but omega cube is 1. So 64 minus 64 equal to 0, which is nothing but right hand side. Now 6 sum can be solved using number of methods. I am using this method. I'll explain. I'm not saying this is the only method. See what I have done. Let me explain. From numerator, take omega square common. To take omega square common means what? Multiply, rather divide each term by omega square. So it is a by omega square plus b by omega plus c. You can check this. Open the brackets. Omega square into a by omega square a present. Omega square b by omega b omega present, c omega square present. Now next step is important. Omega square as it is. Now for these three terms, I have taken omega cube as cm. See, I am not saying LCM, I am saying cm, because LCM of omega square and omega is omega square. Cm means common multiple. And you will understand the reason. If I take omega cube, then it will be a omega plus b omega square plus c omega cube, right? Just a minute. Next step. This is omega square into a omega plus b omega square plus c, or c into 1 upon omega cube is 1 divided by c plus a omega plus b omega square. What remains is omega square, which is nothing but right hand side. Just write this. I'll tell you one more method. See, there are many methods. Now another method can be, see, we have to prove what? A plus b omega plus c omega square upon c plus a omega plus b omega square equal to omega square. That is to prove cross multiply. That is to prove this. Now consider RHS. Open the bracket. Omega square c present. Omega square into a omega cube. Omega cube is 1. So just a present. Omega raised to 4. But omega raised to 4 is omega. Why? Omega raised to 4 is omega cube, which is 1 into omega. So b omega. Yes, that is also present. Right? So this is another method. Right. सेकंड मेथड परत एकदा सांगतो मानस. काय प्रूव्ह करायचे बेटा आपल्याला? न्यूमरेटर अपॉन डिनॉमिनेटर इक्वल टू ओमेगा स्क्वेअर. क्रॉस मल्टिप्लायचा अर्थ कळतो का? म्हणजेच न्यूमरेटर इक्वल टू काय येईल? ओमेगा स्क्वेअर इंटू डिनॉमिनेटर क्रॉस मल्टिप्लिकेशन रे साधं. मग RHS सिम्प्लिफाय कर, ब्रॅकेट्स ओपन कर. ओमेगा स्क्वेअर सी हवा आहे ना, सी ओमेगा स्क्वेअर. ओमेगा क्यूब 1 आहे म्हणजे ए, तर ओरली करता येईल. ओके, कळलं की लगेच तसं टाईप करत जा, म्हणजे मला. सम नंबर 7 इज प्ले ग्रुप सम. प्ले ग्रुप म्हणजे काय? तुम्ही जाता ना ते आधी ज्युनियर के जी सिनियर के जी, त्याच्या आधीचा जो असतो तो प्ले ग्रुप. थोडक्यात सगळ्यात सोपं. पुढचं जरा बरं तरी आहे बाबा. येस मानस, यू आर. Now in sum number 8, use common sense. We have to prove that this is a cube minus b cube right hand side. What are the factors of a cube minus b cube? A minus b is the first factor which is already there. This means we have to prove that second part is a square plus ab plus b square, which is the second factor of a cube minus b cube. Okay. Now open the bracket. So a square minus ab omega square minus ab omega plus b square omega cube. So a minus b into a square. Take minus ab common. In bracket you get omega square plus omega. Now I will write this is a minus b into in bracket a square. I will directly write minus 1 for this. I'll tell you the reason. 1 plus omega square equal to 0. So what is omega square plus omega? It is nothing but minus 1. You can write minus 1 directly, but you have to mention the reason for that. Okay. So this is now a minus b, a square plus ab plus b square. These are the factors of a cube minus b cube. Yes, which is nothing but right hand side, right arm. Now ninth one, prove that a plus b square plus square of a omega plus b omega square plus square of a omega square plus b omega equal to 6ab. I have written this in the beginning only. You may opt to write this afterwards, one and the same thing. Now, what is a plus b square? A square plus 2ab plus b square. What is this? First plus second square is square of the first plus 2 times the product plus square of the second. Now I have added these terms vertically, column wise. Take a square common to get in bracket. See, a square means 1a square. So in bracket you get 1 plus omega square plus omega raised to 4. Take twice ab common, you get in bracket 1 plus omega cube plus omega cube. Here take b square common to get this. Now we have already written that omega cube is 1. So omega raised to 4 is omega cube into omega. That is simply omega. and 1 plus omega square is 0. Now in this step, I have replaced omega raised to 4 by omega, and in the next step, I have put 0 for what? 1 plus omega square. Omega cube is 1. 1 plus 1 plus 1 is 3. 3 into 2ab is 6ab. Okay. Similarly, this is 0 into b square, 0. So we get 6ab, which is nothing but right hand side. Now, third question, if omega is the complex cube root of unity, then find the values of. This question is for homework. These are the answers. Fourth question, if alpha and beta are the complex cube roots of unity, then show that first part, alpha square plus beta square plus alpha beta equal to 0. I'm telling you shortcut method. If your college teacher doesn't approve this, I'll tell you another method. See, alpha beta are given to be complex cube roots, right? So I can say alpha equal to omega. So that beta will be omega square. Now you will say, but sir, if somebody takes alpha as omega square and beta as omega, his answer will be different. No. Why? See this expression, interchange alpha and beta. Will this change? No, it won't. Replace alpha by beta and beta by alpha. That is why this is called as symmetric expression. This expression is symmetric. So it is perfectly right. Now I have replaced alpha by omega and beta by omega square. So omega square plus omega raised to 4 plus omega cube. Omega raised to 4 is omega cube into omega, but omega cube is 1. So we get 1 plus omega square equal to 0. Now, if your teacher doesn't approve of this, then which is other method, you have to say alpha and beta are the complex cube roots of unity. So alpha is minus 1 plus I root 3 upon 2. Beta is minus 1 minus I root 3 upon 2. Substitute those values in this expression, simplify to get 0 as answer, and of course full marks. But in some colleges, they allow this. And I think this method is correct. Nothing wrong in this. Second, then we'll stop. Alpha raised to 4 plus beta raised to 4 plus alpha raised to minus 1 into beta raised to minus 1. No problem. Omega raised to 4 plus omega square raised to 4. Now I'm writing this directly. Basically, it is what? 1 upon alpha beta. Alpha raised to minus 1 is 1 upon alpha. Beta raised to minus 1 is 1 upon beta. But alpha is omega and beta is omega square. So this is omega raised to 4. This is omega raised to 8. And this is 1 upon omega cube. What next? Omega raised to 4 is omega cube into omega. What is omega raised to 8? It is omega cube square. I hope you understand this, laws of indices. Raised into what? Omega square. See, omega raised to 8 is omega raised to 6 into omega square. 6 plus 2 is 8. But what is omega raised to 6? Omega cube square. Why to write like this? Because we have to make use of the fact that omega cube is 1. So this is 1 into omega plus 1 square into omega square plus 1. That is 1 plus omega square, which is nothing but 0. So that's it for today.